Hello, everyone. Great to see you here. Welcome to today's AI Chamber webinar. I'm Agnieszka Gosztyła, responsible for the growth and partnerships at AI Chamber. And today we'll be tackling a topic that many industries know that they should care about, but often don't know how to approach in practice. So it's practical AI adoption in asset-heavy and non-digitalized industries. I'm very happy to welcome today's guest. It's Vladislav Velev, owning partner at Fenny Solution, the AI Chamber member from Bulgaria. Vladislav has hands-on experience building AI-enabled software, cloud architectures, and enterprise-grade AI solutions in complex, regulated environments, including pharma and clinical settings, where move fast and break things is not an option. Welcome, Vladislav. Good to have you here.
Hello, Agnieszka. Thanks for having me. It's my utmost pleasure. And hello to the audience. Happy to be here.
Welcome. Before we jump in, just a sentence about us. So, AI Chambers European community bringing together business, technology, and policy to make AI adoption practical, responsible, and commercially meaningful, especially beyond the obvious digital-first sectors. So, our mission is to empower our members, small and medium companies, by providing representation, a strong voice in national and European consultation on AI policy, knowledge, exclusive insights, legal updates, and case studies that make AI landscape easier to navigate, connections, a network of innovators and leaders meeting at roundtables, business breakfasts, Oxford debates, working groups, and many more business events, and education, workshops, training, and programs tailored to real world challenges and webinars, for example, like this one. So, if you'd like to join the chamber, become a partner, or simply stay in the loop, you are welcome to connect with me directly. I will share my email and LinkedIn profile later in the chat box. And few sentences about housekeeping. So this session is being recorded. You can come back to this session anytime. It will be on LinkedIn. We will spend about 45 minutes on the discussion and followed by the Q&A. So drop your questions in the chat anytime. We will pick them up at the end. Okay? And with that, let's get straight to practice. Vladislav, the floor is yours.
Thanks. So, hello, everyone. So, the topic of the day is pretty self explanatory. It is something that happens to be of utmost importance as of right now, as we have all these industries, all these inherited, let's so to say, industries that are very, very asset heavy and where there should be an upcoming and I'd rather say better get swift to adoption in with the AI and all the expressions of artificial intelligence and everything that comes with this very endeavor. About my humble self, I'm devoted technician turned salesperson for well, I mean not typical one, but I like both processes, both people oriented and technical. And even though I'm not very active technically recently, which means that I currently not having like a primary project, even though I'm participated every here and there. I'm very passionate about everything new that comes when in the technology world, but also with the legacy systems, which are my passion still to this very day. So, long story short about myself, I have occupied numerous roles, both as a software developer and DevOps engineer. And yes, I mean, I covered most of the, let's say, let's summarize like a non-visual part of AI, and including some relatively new concepts like MLOps endeavors, AI ops, and leading projects with investors. And now currently my focus, our company mission, is to acquire more and more touch with the non-digitalized industries and asset-heavy industries, and to help them introduce themselves and broaden their vision when it comes to adoption of respective AI tools, models, etc. So in today's presentation, I'll get to the what I see as most important points with this particular endeavor. And basically, we have six problems here, which you can see, which will be addressed separately, one after another. So let's kick in. So I can easily start, even though they are quite. I mean, there is no single problem that happens to be of the most of primary one, so to say. But reframing the AI problem in having industry. So let me introduce you in that. So AI adoption fails not because AI is weak, to sort in any sense, but because asset-heavy industries are optimized against change. And well, it is pretty self-explanatory, and it is true. So if you trace the history of asset-heavy industries, you can easily get to the conclusion that basically since the industrial revolution, these industries are built to stay. They have to be robust, they have to persist, and they are engineered to minimize variance, not to maximize anything that is dynamic, like the process of learning, like process of innovation, even the innovations. And the machines are depreciated over decades, and even from the very inceptions, from the steam machines, it took a lot of time chronologically in order one certain machinery type to get out of to get to be put to obsolescence, to get decommissioned. And now the trend is the same, even though the machines are way more modern. Introducing to this very new concept of AI is a hardship, really, because these machines are built to operate, and the AI is built to wrap on existing layers of knowledge, insight, functionality, which are not necessarily existing as of right now. So if I have to be a little bit more specific from my experience, from my personal interests in the sphere, a robust example would be AI monitoring vibration data from SKF bearing. SKF is a great manufacturer, I guess from Germany, but I could be very well mistaken right now. But this is a global manufacturer of industrial bearings, and on a hot strip, so hot strip mills, it predicts outer race failures in 40 days. This is a real-time example, real-life example, sorry, that I came across. But the plan ignores it because, shutting down the shutting down the mill costs about more than 200,000 euro per hour. So you can see this is the collision between the traditional, in a sense, and the innovation. So you cannot, you have the AI monitoring, it is effective, but you cannot implement it straight ahead. So yeah, this is the one firm example of the AI problem in heavy industry, because the heavy industry is soon to be put to practical use when it comes to AI adoption, but still it's in very inception. It does its baby steps. Another problem with in this spectrum is the traditional industries are data rich but signal poor, because data existed even before its natural and modern meaning, because data is how we perceive the world. So asset heavy environment generate massive volumes of data, but the most of it is a little bit scattered, noisy, fragmented, and to some extent it is a little bit ambiguous. So good example is sensors log events, and without any context, without a new context, new practical implementation context, the systems could, for instance, if the systems disagree on certain constructs. I provided an example with timestamp, and some other rather banal constructs like ownerships. It could be very easily split between different different streams of operations of data and management. And a good example from real world with this one is a certain industry pump that had thousands and thousands of sensors reading per hour across the programmable logic controller. This is the industrial computer that directly control machines, and there are several standards to that. But this is a technical, in-depth stuff which is not relevant as of right now. So the supervisory control and data acquisition and the ERP systems, they displayed a firm inconsistency. So as you can depict from that, it is data rich, it's super data dense, but the data happens to be inconsistent to the very context of AI, because from AI point of view, of certain models point of view, this is inconsistency because the logic in this particular example is way more human than AI can handle as of right now. AI is an umbrella term. By AI, I usually refer in this context to specific models that are built, trained, executed for particular cases. So they are relatively incapable when compared to large language models, just for your context. Another issue, not issue, sorry, another problem that we can easily come across is the digitalization by itself, which is not the same as intelligence. When something is digitalized, it means that it depicts and displays the effort focus on visibility rather than the decision quality. So displaying something doesn't make it easy to wrap with a layer of intelligence. A good example would be dashboards, reports, and automated data flows that are inherited data flows that describe everything that has taken place, any action, but they do not influence the decision what should be performed next. And in the pragmatic, so to say, IT activities, we have witnessed the following: the dashboard shows everything and is drifting out of spec, but no system tells the operator what decision to take, only that something already went wrong. Scenarios are um, especially when it comes to the operations part of IT industry, like in DevOps and platform engineering. The examples are thousands, really. You can imagine one monitoring system that is not proactive monitoring system, that simply indicates there is an error, and the error is not very well specified what should be taken, how you should take care of. Well, the same is with the AI. I mean, sometimes it's very difficult to let the layer of intelligence takes its course and to rely completely on it. It's a tough decision, and the same issue is present here as well in this context. And so, what makes the asset heavy industry special? Because there are lots of industries that implement AI heavily, but the asset heavy industries are special due to some some properties that they express. For instance, the high capex inertia, the machine outlive software cycles. Basically, we covered most of that with our first slide, because the asset heavy environment, the physical equipment is designed to last, to operate reliably for decades. For instance, while the software platforms, they evolve with lots of more moving parts, because there are certain expressions in the software development process that can be easily outlived by the natural progress. But when it comes to the moving parts, the physical equipment, it's not like that. I mean, then there you have engineering cap that can be easily reached, because you cannot do a lot better differential. It's like currently maybe it peaked, it's the best, but it's not the same when it comes to software. The software could be always improved, and we face this issue when we try to digitalize the industry. So AI initiatives that assume frequent system changes and rapid changes in general when it comes to the software level, the deep hardware integration collide with the reality, and it is very difficult issue to address. And it is prevalent in the other industries, like of course automotive is a very good example, but still in the asset heavy industries is a lot. A lot more pronounced because I can provide you an example with a gas turbine, which we had with one our partner company. They had that case. So a gas turbine, it was installed in 2005 or something like that. I mean, in the beginning of the millennia, and it was expected to run its lifespan run about 30 years or so, something like that. But they introduced actually an AI model built to optimize the operation needs, and it required frequent software updates and new data interfaces that the original controllers simply didn't manage to maintain and to implement. And it was never designed in the first place. So the intelligence must adapt to the machine and not the other way around. You cannot change a working machine. As we say in the software industry, if something works, don't touch it. There are several interpretation of this particular grain of wisdom. Another issue is the operational downtime costs. And this is something that all the industries once again encounter, but basically in the asset heavy industries, it's a lot more pronounced. Operational downtime cost is can easily go to some crazy costs, and it could be the borderline between fail, bankrupt, and good operation. So downtime translates directly into lost revenue and all sorts of risk, safety and penalties under heavy contracts, and as a result, systems are optimized to avoid disruption, and experimentation is viewed as operational risk. And I have to open a bracket here. Basically, this is the greatest, in my personal opinion, of course, this is the greatest hardship when it comes to software development in this area, because you cannot freely experiment, and the quality assurance process is rather a hardship. And not in any case, of course, but sometimes you can't simply test reliably, or you have to create very heavy installations for testing out your code with not greatest not greatest reliance, but it is what it is. A good example, maybe if I have to, is a power plant that had an AI model that want to retain using live turbine data with all sorts of indicators and turbine data stuff, but testing it in production risk even a brief instability that could trigger grid penalties. Into power grid reality, you cannot just turn off highly operational unit like this said turbine, because you simply can't. I mean, you can imagine even nuclear power plant, you cannot turn it off. So in this case, the model was paid, it was created, it had to be successful, but it was never allowed to run live, so nobody took the risk. So operational downtime costed a lot and wasn't worth it. Another good example is the uh, fragmented data ownership. So we have these three streams, like the operational technology, the IT, and the management, and usually they go in their separate ways, in their own way. So in asset heavy organization, data is produced, stored, and governed by these three groups. And long story short, operational technology focuses on safety, on the uptime. IT is the IT, so it integrates the entire solution, it develops it, and etc. And the management usually is pushing for the results. And this is a severe fragmentation. It exists in some other parts of the industry, of course, but here is a lot more pronounced. A good example in this case would be an AI that detects, for instance, abnormal vibration on a compressor or some other moving part, turbine. It doesn't matter. But the operational team owns the sensor data, and they take the decision not to stop the machine and not to put it out of operation. The IT department, they own the platform, the deployment, and everything software related, but can't interfere operationally. And the management has bought. So we have abnormal vibration on one hand, we didn't stop it. We have data, we didn't react, and they only seek for the monthly reports, and nobody acts in this particular case. So another point that makes the asset-heavy industry special is the regulatory drag, compliance, bit optimization. So yeah, this is the greatest burden of all, at least of my humble opinion. So regulations, especially when it comes to the territory of European Union, can go in quite severe way and can easily obstruct the entire process. And asset heavy industries are not only not exception, but basically they and pharmaceutical industries are the most heavily impacted ones. They operate under regulatory regimes that prioritize adhering to the regulations. I mean, they're a must. You cannot go beyond these regulations. Processes are designed to be explainable and defensible, even though this is an interpretation. I mean, there is a lot to discuss. This is regulations by itself is a topic for another webinar. It's a great burden, great pain, and there are numerous examples with that. But for instance, one example from practice, if I can interpret, it is a certain AI model. It detects. It's actually, and I can provide you an example from the Bulgarian manufacturer of heating vessels. I'm not sure. We call them boilers here in Bulgaria. I'm not sure about this technical term, but boilers, water heater, whatever. So there was a temperature alarm that could be raised by 5 degrees without risk to reduce some sort false alarm, so of false shutdowns, and to trigger the preservation of the vessel. But the alarm threshold is written into the regulatory compliance documents. And in the European Union, somewhere it is firmly said that boilers can't go beyond these degrees. Like, that's that. And the manufacturer was who found themselves obligated to adhere to this rule without any sort of option to improve that, to comply that, to complain about it anywhere, to make some adjustments, and basically squeezed by the release date of the new product, they adhere to that, and they excluded one certain feature of the entire production line. Which feature I forgot what that was, but it was some boiler feature. So regulations is some intense burden and hardship which has to be overcome. So when it comes actually to where this AI works and where it doesn't, we have few very prominent cases. So I'll start with when AI fails. So AI fails when it is introduced before data discipline and operational quality are already established and are already an integrated, vital core of the whole. So basically, when data is damaged and inconsistent, when it is poorly uh, I provided an example with the timestamped and or context free, but you can imagine, and data can be not good in so many different scenarios. So AI amplifies noise instead of reducing the issues. And a layer to AI is basically can be a big fail, and I witnessed that personally, not with only with these particular endeavors for the needs of the asset heavy industry, but also with all sorts of other programs. So, for instance, one Bulgarian company tried to introduce um, AI heavy process in one CRM that was um, that was designed with some very scattered data in mind, at least in my opinion, and it was a complete fail. I mean, it was a very ambitious project, but it failed. And when it comes to the more pragmatic and asset heavy meaningful examples, like, it is the signal mixing. The signal mixing is some super real issue with the heavy industry. When AI flags, let's say, a robot arm as an unstable, but half of the instability, for instance, vibration data is time-stamped by different units, like different like controller or some other operational unit, or by the camera. So the engineers can easily get to an argument which signal is real and which is reliable. So AI as well is not capable of taking the educated decision by itself. Another scenario of fail of AI is when it attempts autonomous decision making without human override, and frankly, this is the very scenario that more engineers imagine in first place. Like, we have some heavy machinery that goes straightforward and does this particular thing and this thing only, and some ambitious engineer decides that it could be uh, the machinery could be introduced to new functionality which could be uh, made by AI because it's an easy decision. And I've personally witnessed that such opinions and such suggestions by engineers a lot. And decisions in these systems carry safety of all sorts: regulatory, as I mentioned, financial, and operational, all sorts. And fully autonomous actions usually are placed upon years and years of testing and very controlled environment. So introducing to AI disrupts disrupts processes that are grounded so deeply into the fundamentals of the very process that it's very difficult to predict. And an example in practicality of this one is an AI triggers like an emergency stop on a robot arm based on detection of some sort of pattern recognized as unreliable pattern. But because no human confirmed the risk, and it it has a pass for this award is issued, then then there is an inconsistency. Like, supervisors refuse to let the AI control the safety actions again, and it happens more over than you can imagine. It happens a lot that some AI is purely tested, or um, some scenario emerges where nobody predicts it. Another point of failure is uh, when it is framed as an end-to-end transformation rather than a scoped intervention. So end-to-end narratives expand scope faster than the organization can absorb change. In asset-heavy industries, it is very a very good example for this one, because the responsibilities can very easily go to the rather blurry side, given the fact that, as I mentioned, usually the processes are established and tested through years, even decades. And now there are different narratives that are very easy to suggest, inspired by the AI advent. And so people are having a lot less apprehensions than they should when introducing AI capability. And one real world example that I came across, not with my project, but with some peers' projects, was there was a power plant that started an AI transformation in a testing plant, but it doesn't really matter. I mean, there was a scenario for AI transformation to optimize all equipment and everything that was leading data to to the plant itself, to the operational unit, like data pipelines and workflows, and they started at once. So about like more than 1 year later, they still didn't have a single deployed model for predicting failures of the units like pumps and mechanical parts and something like that. They weren't even close, and it was planned a lot, but it never came to fruition. So this is where AI fails. But the good news is that there are lots and lots of scenarios where AI actually works. And one such scenario is AI works when use cases are very narrow and they are stable, they're well established, and they're operationally bounded. It's pretty self-explanatory. I mean, there is not much to say here, but when you put AI atop of something that is well operating, something that is well established, something that we are very familiar with, it's different thing really. And of course, yeah, well, I mean, there is some management drag here, like when the management decisions are taken rather recklessly, but it's another topic. But well-defined use cases limit variance and make outcomes predictable, and the stable operating conditions are a must. Without them, we're not talking big business really. So one example for such success was vision inspection, so matches vision inspection, which was quality assurance inspection of visible components. I mean, physical component, not visible. So the AI basically was checking whether a single connector was properly connected to one chipset, or it was something like that. I'm not sure about the term, but if there is a well connected connector, physical one, and if it is placed on the assembly line, and it was detecting very very precise measures when it comes to uh, connection physical connection failures. And there was a very clear pass fail rule. And when it comes to visual assessment, maybe this is in my experience, at least, this is the field where AI is the most reliable. It tends to detect inconsistencies very well. Really, it is impressive of sorts. Another success story is when AI, uh, so when the objective is variance reduction and not full automation. Full automation, it is a mirage, really, even with the less sophisticated work. For instance, I have great experience from the dawn of the DevOps activities. So back then in 2012 or 2013, everybody was very eager to automate everything using the classical expressions. Python was just becoming popular, but also we had Perl and PHP. And even back then, there were so many fails with people trying to automate everything. The banal stuff like adding the TCL scripts atop of some Python and stuff like that. It never worked good. I mean, never. It was never reliable, even though some ambitious engineers tend to argue that they can do it. Well, it is the same in this case, and it is even more pronounced. But basically, the good news is that in AI, we have established good practices when it comes to narrowing the operational variance. So most operational losses come from deviations, not from average performance. And reducing variance improves reliability and predictability and everything. Uh, One particular example was with one assembly line torque control. So that's why I provided this image actually. And there were some sort of AI flags when the robot applies slightly inconsistent bolt torque. It was screwing bolts, and there was there were some mechanical inconsistencies that weren't established, but it was due to the quality, not quality, sorry, change of the material, change of the metal, and prompting the operator adjustments that keeps every assembly within tolerance instead of chasing maximum speed of execution. And you see, in this example, we have an example, also included example in for another great practice: interaction between AI and decision making of human being. So the AI doesn't make the decisions to its full extent, but rather outsource this capability to an operator, to a person, which is, I believe, which is necessary, at least at this point. So another point would be, mm, when AI augments existing workflows instead of replacing the decision ownership. How it differs from the previous example is we have an established workflow which simply cannot go wrong because it is very well established, as I mentioned. So AI creates value when it reinforces how decisions are already made rather than attempting to redefine authority. And yet, this is the entire paramount concept of automation itself. You cannot automate anything if you're not in depth involved in its operation, how it actually works, and what it consists of. So a good example with this one would be a maintenance workflow. So AI ranks uh, maintenance tickets by risk and urgency, but the maintenance lead still decides what get fixed and when. So to a sort, a layered approach. But yeah, this is the necessary evil, I guess. So uh, when we're talking about the practicality and how the entire framework, even though I'm not sure if framework is a good term here, because we tend to use rather standard and traditional software terms into this entire different field, and I personally find myself lost sometimes. But long story short, it operates in four-layer paradigm. So the signal layer basically consists of the raw inputs. They are generated by existing systems, sensors, cameras, logs, external systems, and data entry by people even, and so on and so forth. And the funny part is that most of the time this layer already exists. This layer is already well developed, and usually the case is a matter of how do you rearrange that. And the rearranging itself, it comes from the normalization layer. This is a little bit tricky, really, because normalization layer is also established to its great extent, because usually it is being expressed by the traditional software constructs like embedded programming languages and some other expressions. But the thing is that the normalization layer is where the raw signals are converted into usable inputs through some mm, through some activities, and uh, most implementation efforts lives here because inconsistencies compound quickly as data moves downstream. And the next layer which happens to be of interest of the topic of this webinar, is the intelligence layer. Intelligence layer, uh, intelligence layer should not be mistaken by the next layer, decision layer. I mean, they're separate, like they're absolutely separate. So basically, the intelligence layer applies these analytical methods to the normal, already normalized data. So it is the layer of detection for the anomalies, for the inconsistencies, and usually the best case scenario is to use many in number or more in number, but simple models, which usually outperforms complex models. And it is absolutely easier said than done, absolutely. But intelligence layer could be summarized as clarifying decisions and not introducing additional uncertainty and adding all the expressions of the next layer, which next layer is the decision layer. And so basically, this is where the AI stands by definition. The decision layer, it translates the insights into action through different different um, uh, different actions like alerts, dashboards, thresholds, and the effective system. They usually present information at the moment as it is needed. And without functioning decision layer, the intelligence the intelligence retains its very confused and uninformed state, and it's not generally possible to its full extent. So when it comes to the implementation of everything AI related into asset heavy industries, and as I mentioned earlier in this webinar, so economics is kings, really. So the the capitalization, the return of investment is what matters the most in the end of the day, because here as this industry differs from the traditional software industries, usually the stakes are very high because we are working with already established businesses, institutions, factories, etc. So the return of investment is driven by variance reduction and not by innovation. And it is basically the opposite of the traditional software industry. The economic value comes from narrowing the spread between best and worst outcomes, not from occasional breakthroughs. So stability is the key factor here, really, and the key feature. And executives usually fund system that makes results very repeatable, very predictable, and not the one that outperform without displaying outperformance consistency. And it is very difficult to prove this um, performance consistency that is about to outperform the traditional implementation, because usually the teams simply don't have the time. So when it comes to return of investment, no, sorry, not the return of investment, it's pretty clear, but I can provide you another example. So the AI can reduce unplanned downtime for about several hours, like 10 hours per month, to a consistent 4 to 5 hours. It creates more return of investment than the one that occasionally predicts a major failure. And when it comes to selling this idea, it is very difficult because the sales pitch usually revolves around mm, providing good predictability of major failure instead of consistent small fails. So it's a little tricky. When it comes to the economics, small percent efficiency gain beat moonshots. This is how I this is how I situate this one. So in a capital intensive operations, the minor efficiency improvements compound across scale and time, and this is what this is what happens to be of great value. A good example would be an AI that reduces a compressor or some other mechanical parts energy used by 1% every hours or even every day. It saves more money in a year than one big shot, one big time optimization that only works under some perfect conditions or circumstances. So consistency is absolutely the key. So cost of false positives. This is a very pronounced feature in this industry. So cost of false positives, cost of missed insights in heavy industry, they consume attention, they trigger unnecessary interventions, and they erode trust in the systems, in the investors, and basically they bother the communication. And each incorrect word carries real operational and financial risk and cost. Examples are numerous. So, in a AI falsely flags of bearing, in a bearing, for instance, as failing, the line is stopped effectively, and the bearing could be very well replaced because they are these mechanical parts, the bearings, they are very difficult to maintain and to repair, but they're replaceable, still very expensive. And the plant loses more money in downtime than the bearing would have ever cost if it actually failed. So the false positives are a great trade-off. They're also usually deeply enrouted into the contracts, so there is a huge risk with them. So AI should be owned by IT and not the operations. And this is not very self-explanatory, but usually, and of course, a lot of respect for the colleagues from the operations, but usually they think of AI as something that they understand in depth, something that is very easy to prove. You can imagine that. Everybody can create an example scenario and try to implement it in chat gpt for some example outcome. Hey, chat gpt, do you distinguish this from this? But it's not the case when it comes to custom models for this kind of regulated environment. So when AI ownership sits with the IT, success is measured in deployments rather than the outcomes. And this concept is very difficult to be introduced to the management and to the decision makers. And without operational ownerships, even technically good and established system, they fail to change behavior. And uh, an example here would be a dashboard that nobody acts on. So some AI department like deployment build team or whatever, they deploy a AI dashboard showing up uh, anomaly risk. But when an alert appears, operator says, IT owns the system, not us. And so there is shifting responsibility and all other possible scenarios here. But basically, the roles should be segregated when it comes to the implementation. So another topic is the organizational traps, because everything is organization, and AI doesn't differ from this golden rule. So, long story short, uh, there are lots of scenarios that never reach production. So, as I provided the example with the pilots, they success under ideal conditions but collapse when exposed to real operational constraints. And when a certain AI solution is have been constrained for from good development, from good quality assurance, but it succeeds anyways, then it usually gets to that point. So when you train an AI pilot with clean historical data, which is pulled, for instance, once a day, but production data arrives a little bit later, out of order, with some missing fields, all sorts of data corruption scenario. So the model works in the pilot and immediately degrades in real operations. And it's very difficult to predict. I mean, when in this particular example that I provided, the model is trained by historical data that seems very sound because it's provided, but it is inconsistent due to this unpredictable circumstance of providing it in late of the day. So the pilot success depended on data conditions that never exist in production. And for a person that trains models, all possible scenarios are impossible to grasp, really impossible, because this person will never have the full context of the operational aspects of a certain heavy industry. And another trap is that vendor they sell platforms instead of outcomes, and well, this is just a practicality issue because vendors they would absolutely prefer to send an entire solution due to some some concerns when it comes to the pricing. But basically, platforms they promise flexibility, but they defer responsibility in lots of cases. And organization tend to buy tooling while assuming value will emerge later. It's not the case. Mm, I witnessed that so many times, not even with the AI, but you buy certain tool. Well, even I have bought some tools that happen to be absolutely redundant. The latest example would be one CRM system that we didn't need. We bought it anyway, and we're sorry about it, but it is what it is. And one another example would be a flexible AI platform that's being provided by a certain vendor that do predictive maintenance and quality inspection and everything else that you can imagine, forecasting, but no single use case is contractually committed. And so after installation, everybody asks, so what do we need this for? What do we build first, for instance? And when it comes to the last point is the authority lock-in. And the AI adoption is sequencing, sorry, not sophistication. So most failures come from doing the right things in the wrong order. And this is so true. So basically, all the authorities they should work as one, which is absolutely easy to say, but very difficult to implement. And the system's maturity they actually grow by accumulation, not from some great leaps in the execution. But this is more of a human aspect of the entire issue. And another human aspect is the data discipline. The data discipline is something that should be already established, or it should be at least attempted to be established before introducing the AI. But it is very difficult to combat the data ambiguity or to fix the data because the business itself doesn't work like that. You cannot just jump in as an AI guy and to say this data is bad and I'll fix it for you, because this is not how the sales work in this particular example. Absolutely. And also control beats autonomy in the asset heavy environments. So yeah, control should be pushed at all times, and system that preserve control they integrate more easily, absolutely. And autonomy increases theoretical efficiency but concentrates risk. So control before the the everlasting seek for autonomy. And so that was that. I'm open for discussions if you wish.
Valisa, thank you very much for this very practical insights today. Actually, we have two comments in the chat box. Maybe
Mhm.
I can read this from Piotr. Piotr wrote us. Maybe I am oversimplifying, but what I get is that AI works great in heavy industry where we all have a work for perfectly match. We have correct sensors in the right place. We monitor everything and gather proper data. We know 100% of the process. Then the AI compare data with tolerance of this parameter and inform whatever it is good or bad, so operator can, for example, stop the machine.
Mhm.
Then it is just a comparison. Why do we call it AI? Isn't that a little bit of force naming? I understand predicting some patterns which can be not seen, but actually it can be done offline by sending data for analysis.
Mhm. Yeah, absolutely. Yeah, well, uh, providing the correct terms is part of the game, so to say. So the thing is that the AI is the new methodology of execution almost everything. So this actually is a very relevant comment and the very relevant question because yes, usually AI to just to throw the term AI to everything is a little bit of an overkill. But AI itself consists and represents an entire universe of new possibilities with within whose context we will be executing even the small actions. So when it comes to the terms, if something is being handled, some easy and commonplace task is being handled by the AI easily, then it's once again it's an artificial intelligence solution, even that it could be easily overcome by what I say traditional approaches. The thing is that when you have an entire framework of artificial intelligence, you should adhere to the new ways because these are the new ways. And if you do something manually outside of that, then these manual efforts they could very easily heap up and then should be corrected. But yes, the the thing is that we have to adjust the AI opportunistic layer to all the tasks from the easiest to the very complex.
Thank you very much. We have 2 more minutes. So, does anyone have more questions? So, free to ask. And I have one more question. Vladislav, so how do you sell the things? How do you work?
Difficult. Well, uh, basically the approach should be the approach should be adhered to the following sequence of selling points. So you have to adhere to what I mentioned, to being as consistent as possible, as realistic as possible, not to be very adventurous when it comes to automation of good established parts. And the thing is that one should know the business and one should know the limitations. Usually the best approach is to get familiar with the industry itself. I mean, this is absolutely self-explanatory and obvious observation, absolutely. But the thing is that there are even small parts of the non-automated endeavors in each and every asset heavy industry. So if you observe for a certain amount of time the activity of the workers, of people that are over there, and whose efforts you should substitute with artificial intelligence, a lot will emerge. So one should never be in a rush with suggesting some end-to-end solution. And also, there is no end-to-end solutions. This is the main thing. No end-to-end solution. You should instead provide a paradigm of lots and lots, maybe small solutions that work in a sequence, that work dependently with each other or independently in some cases, rare cases. But the thing is that you should also solve a practical issue.
Okay, thank you very much for that.
With pleasure.
So also thank you to our audience. Thank you for joining us today. It was a real pleasure. Just a quick reminder: the recording of today's session will be available on LinkedIn. Taking this opportunity, I would like to invite you to our next webinar. It will be on 11th of February. AI and HR. It will be the topic: inside AI-driven recruitment, how hiring decisions are really made on. So we would love to stay connected with us, with you. So please follow our profile, enjoy our upcoming events. And of course, if you have any questions, feel free to contact with us. So thank you very much and have a wonderful day and see you
It
next
was a
time.
pleasure. Thanks for having me. Have a good
Thank
one.
you. Bye bye.